Hi, sir.
Hello, how are you?
I'm good, thank you. How are you?
Very good, thank you. So, we started with circles for your GCSE level A. Now, this is our third lesson on it. In 2 lessons, we completed kind of all you needed. Today is the time when you can ask me questions. You must have gone through all the review exercises. How comfortable are you?
Yeah, quite comfortable. I was quite surprised how in 2 lessons we completed like a whole unit. So yeah, I feel very confident in attempting most of the questions from my book.
Very good.
Um, After today's lesson, since it's like an exam review, I'll do the like exam section of my book, and then I'll see like how much I know. So yeah,
That'd be
uh,
great. Yeah.
yeah.
So the whole idea was to keep it simple, but give you thoughtful examples which could help you do the needful. That's the whole idea, right? I don't really want to burden you with hundreds of things. On my channel, you'll have many videos to go through. And in the book also, you have many questions to work on. Now, it's a good practice whenever you come across any question where you have any doubt.
Mhm.
You have to be absolutely clear because we're trying for here marks which are very close to 100%. Okay. So any doubt anywhere, I like you to just get in touch with me so that we get through that. And when you sit for the exam, you just nail it, kind of, right? Okay. So based on your feedback, I have actually selected few more questions. And this lesson, what I want to do here is, we want to do interaction of a circle with a line. So the whole idea here is that if you have a circle and if you have a line, now that line could be outside the circle, it will not even touch it, right? Or as it may just touch it, it becomes a tangent at a particular point. And it may go further and may hit the circle, cross at 2 points. So you have 2 points of tangent, I should say, points where it will cut the circle, no tangents, of course, but that will
Like a
form a chord,
chord.
like a chord. And then
Mhm.
might move further, getting to the tangency point and then move away, right? So you can see that a line can actually move and cut across the circle and move outside. So that leads to one set of questions where we're talking about equation of a line, equation of a circle. We'll use a parameter, let us say k, in the line or on the circle equation, and we'll say, well, what is the condition under which this line will be tangential, this line will cut across at 2 points, or it will not at all touch the circle. So these are the three
Right.
conditions which will normally happen. And for that, you have to find the value of k, rather the range of values of k. It's kind of an inequality. You understand? So in GCSE,
Yeah.
you have many times such questions, right? Where you have to solve this inequality and get this answer. So based on this, I've taken one example. The next
Oh, okay.
example is, yeah, and the next example is to find the area. Now let us say that the line, this is a circle and the line cuts through the circle, you get a chord and you have a center point. You need to find the area of the triangle formed. So that is second kind of question, which is kind of difficult on this particular topic. So that is another question. And to begin with, just to get you started, I have two simple examples to give you the concept. So then it will like move you into this stream of videos. Just a couple of questions and sail you through your examination style questions. So that's the whole idea. So let's begin with this lesson and see where it goes. Okay, there you go. So you see a set of 5 questions here, Amy.
Yeah.
So these are the 5 questions which I have selected for you, and understanding their solution should help you to do 90% of your questions in the book, including the exam practice. So can you please read the very first question for me?
Yes. Question 1. The line x minus y equals a intersects the circle x minus b whole squared plus y plus 7 whole squared equals 50. At the point a minus 3 minus 8. So find the value of the integers a and b.
Correct. So that's a relatively simple question. So what we are saying here is simple, that this particular line and the circle have a common point, which is A, correct? Now, since
Mm.
A is a common point, we can substitute this value minus 38 in the first equation, find the value of A, and we can also substitute this value in the second equation and find B. Nothing could be simpler than that. However, even this question sometimes throws the students off, right? Do you understand? We have a point A, which is common to both the line and the circle, right? So I can substitute this value of x and y, which is minus 3 and minus 8, in the equation line. So when I say minus 3 and minus 8 will become plus 8, right? So minus 3 plus 8 is 5. So we get the value of A as 5. Do you see that? Such a simple question. And on the other side, yeah.
Oh, sorry. But like when looking at that question, I just realized, you know, when you pointed saying you just, because that's a common point, you can put it in both equations.
Yes.
I think I would have, if it was an exam like condition, I would have, like, you know, the line equation.
Yes.
Since we found A, I would just try and find one, sub it back into the circle.
Correct.
And it would have been like crazy. Yeah.
Yes. I have seen those kinds of solutions, and that is why I took this question right in the beginning, right? So when you see a question, you have to see a strategy. You should not just isolate x, substitute there, and then try to solve a quadratic equation. It is going to be hell, right? And the time wasted in such a simple question will cost you a lot as you move forward. Is that clear to you?
Right.
That's the first question.
Yeah.
It makes sense, simple as that, but gives you a strategy to work around. Okay, question number 2, please.
Find the equation of the circle passing through the points A, 0, 2, and B, 4, minus 2, with a center on the line x minus 2y equals 3.
Correct. So we have 2 points on the circle itself, and then we are saying that the center is on a given line. So, Amy, how will you answer this particular question?
So since the 2 points are on the circle, could we like form a chord and then between the 2 points and then do the right bisector?
Perfect.
And then, yeah, work from there, I guess.
Right bisector will intersect the line, giving you the center, and there you go. Center. So you have all the components, and you need to find the radius, of course. Once you get the center, then use any one of these points, find the radius, and then the circle equation. Perfect.
All right, yeah.
Question number 3, please.
The line x plus y equals 13 intersects the circle x minus 1 whole squared plus y minus 6 whole squared equals 20 at the points A and B. Find the area of the triangle OAB, where O is the center of the circle.
Correct. So it's kind of similar to the previous one. The only thing is you need to find the area. You know the chord, right? You know the right bisector. So you have to find the height and the base. Half base into height could give you the answer. Question number 4, please.
Right. The line y equals kx minus 2 intersects the circle x minus 7 whole squared plus y plus 1 whole squared equals 5 at 2 points. Find the range of k.
Range of k. Now, this is the question which I started off with. So we have a circle, we have a line given to you, correct? And now, in this particular case, in the equation of the line, we have a parameter k. Correct? So that is the slope. Clearly, the slope means it's like a scanner, right? So it's like moving all around, correct? So somewhere in between, you have a circle, right? So somewhere you have a circle. So obviously, when you're moving all around with this value of k, which is the slope, there will be an instance when it is going to be tangential, correct? Like this. So we are interested in these 2 tangents actually. Perfect. Now, when you substitute the value of y right there, then you have an equation which is a quadratic equation which involves k. Now that quadratic equation will have a discriminant. You remember the discriminant d, which is b squared minus 4ac. So it introduces to that what you learned during, simultaneous equation working with quadratic equations and linear equations. So that concept. So now you have this b squared minus 4ac. Since we really want 2 points, the idea here is, for me, I will always calculate when is it 0. This is simpler. So when I find when it is 0, then I get 2 values of k, which are these 2 values. Is that clear to you? Right? Yeah. Now, I get these 2 values. Now my question is, what is the condition when it touches at 2 points, I mean crosses at 2 points, or it doesn't touch at all. So that means we'll say, well, one condition is K is between these 2 points, correct? That is when we are talking about 2 points. Is that clear? So one condition
Yeah.
could be, you know, when K is equal to this point, that means tangent, correct? And one condition
Yeah.
could be either K is greater than or K is less than that point. Is that clear to you? So just finding the points where it is tangent helps you to answer all three kinds of questions. Correct. So many
Alright.
questions. One question will be like, when is it tangent? One, when will it not touch? When will it cross at 2 points? So all these questions are solved by this strategy. Find the points where it is tangent. Simple as that. So that will give you a value of K, right? So that gives you a range of K. If you are beyond that range, then you're not touching the circle at all. If you are just at those
Right.
2 points, tangential, in between, there you go, you cross at 2 points. That is what it is, right? So that is question number 4. Now, can you please read question number 5?
Yeah. Two circles P and Q intersect at the points A and B.
Correct.
Find the area of the quadrilateral PAQB if the equation of the circle P is x squared plus y squared plus 10x plus 6y plus 14 equals 0, and that of circle Q is x squared plus y squared plus 20x plus 16y plus 154 equals 0.
Perfect. Now, remember one thing, whenever we're talking about circles, every circle has a name, and the name is given by the center. So when I say the center is P, then that circle will be called circle P. The other one is Q. That means the center of that circle is Q. Understand? So circle P seems to be smaller, so we'll write P here and we'll write Q there. That is first thing. Now, these two circles which are shown here are intersecting at 2 points. Let's call them A and B. We can figure them out later. Now, the important thing here is to understand that we are talking about these sides, correct, which form the radii of P, right? So they are equal.
Right.
So we know that these two sides are equal, and we also know those two sides are also equal. That means we're talking about a kite. So the quadrilateral which we are talking about, PAQB, is a kite. So we have to find area of a kite. So that is how you have to understand the equation. And just moving around, finding intersection and solving quadratic equations, one part of it. After that, what? We need to find area of the quadrilateral, correct? And this quadrilateral is kite. Now tell me, do you know the formula for area for the kite?
Yeah. So isn't it the diagonals, product of the diagonals times a half?
That is absolutely correct. So you should know the formula for the kites, which is, Amy says, half of the product of the diagonals, right? That helps. Now let's move on and see how to really solve it. But I hope you got the gist of it. At this stage, I will encourage the students to pause the video, answer all these questions, right? And then look into our solutions. They will just help you to confirm the answers. I hope you have understood the strategy, right? So let's begin with the very first thing, which I always prefer to put the formulas first. So here we have a list of all the formulas which we should know when we are going for circles, right? The first one is, if the center is 0, 0, that is the origin, and the radius is r, x squared plus y squared is r squared. If I change the center to hk, then it's like a transformation. So x minus h, y minus k will replace x squared and y squared equals to r squared, and you get your new equation. Now we are also very fond of writing this equation in a particular form, which is, so we also know that the circle equation in the standard form is written as x squared plus y squared plus 2gx plus 2fy plus c equals to 0, where the center is negative half of this term, that is the x value, negative half of the other term, so minus g and minus f, and the radius can be calculated by squares of these two minus the constant c square root. So that is another relation which connects all these things. We also learned, which is new thing and not in many books, which is that if you're given the diameter points, which are x1, y1 and x2, y2, in that case, we can have product of that difference and this difference. Some will give you the equation of the circle, which we easily derive because once you know the diagonal, in that case, you know any triangle formed will be right triangles. So the slopes will be negative reciprocal and easy derivation to this very important formula. And then the distance formula you use so much. Finding right bisector, you need the midpoint formula, which is right there. The equation of the lines could be written in many different forms, which we have mentioned here. Here is the distance formula from a point. Now, many times, especially to find the area of a triangle, you need distance from the center to the chord. Use this particular formula, where ax plus by plus c equals to 0 is actually the equation of the line, and you substitute x and y to the point x1, y1, and get this particular result. So the distance is ax1 plus by1 plus c, absolute value, divided by square root of a square plus b square. Also, in this particular case, we'll need area of the kite. So the kite is shown to you here, right? So kite has these properties that the diagonals really intersect at right angles. That is very important. Now, these two sides are forming the radius of a circle will be equal. Now you can think about two particular triangles and you can add the area of these two triangles, which is half base into height, right? So we have these two triangles. We are calling them as triangle A and B for the easy derivation of the formula. So that is the triangle A2, which is half. Base is the diagonal, one of the bigger, longer triangle. That is the diagonal B, and A by 2, the half of the other diagonal. Similarly, we have the other half as the area of the next one. When you add them up, you get your formula, which is B times A divided by 2. So once you have a visual look at this, you'll never forget that the formula is half product of the diagonals. Is that clear to you?
Yeah.
Now let's move on and take up the solutions. The very first question was so simple. We are given that the line x minus a equals to a intersects the circle x minus b whole square plus y plus 7 whole square equals to 50, and the point of intersection is A. So this is shown here. This is the point A, which is on the line and also on both the circles. I mean, why did I draw both the circles? Well, we have to look into that part. However, consider one. And since the point lies on these points, well, easy calculation for A, substitute, find the value of A as 5. The second one, we are given the equation, substitute x and y values as we have done here and calculate. Well, we have b square when you open this up, correct? So since you have b square involved, now see here, this is also a good way of solving your quadratic equation. I really did not expand 3 plus b whole square. Do you see that part? We had a number here,
Right.
it was minus 1. I just shifted that number on the other side, so I got 49. At this stage, I've done square root both sides, and when I do square root, I get rid of the square thing. But whenever you do square root, you have to write plus and minus, right? So you have to write plus and minus. I forgot to write here, plus and minus. So 3 plus b is plus minus square root of 49, and that gives me two values of 3 plus b, which is plus and minus 7. And so b is either minus 10 or 4. Since we have two values for b, you can clearly see that we have two circles. Did you get this idea, right? So now we have two circles to work with, and the diagram illustrates that particular thing, correct? So find the integer values of a and b. Remember, you could have two values of b, and if you write just one value, you may lose some marks even for such a simple question. Is that clear to you? So remember, whenever you have to do square root, take both plus and minus into consideration. Okay?
Yeah.
Next question here is, find the equation of the circle passing through the points. We are given a as 0, 2, b as 4 minus 2, with the center on the line x minus 2y plus 3. So I just sketched a line, this line here, whose center somewhere. So that is the connection between these two. Now the 2 points which we're talking about, A and B, are forming a chord. So clearly for us, if I have the right bisector of the chord, right? If I have the right bisector of the chord, it is going through the line. So that means I do get the center point also. Clear? Now, for such questions, our approach is going to be kind of like this. So, approach is find the right bisector of the chord AB and BC. Find the center O as the point of intersection of the right bisector and the given line, right? So that is what it is. That will give you the point of intersection. So what we did here was we had a point which is the center point 2, 0. Then we have to find the slope, and the negative reciprocal will be the slope of the normal, right? So this is the slope of the normal. Okay. Now the equation of the line will be perpendicular. So what we have here is not x minus 2y. This is the right bisector which we are given here. So this line is the right bisector. Correct. Now, I have not really shown this line, which is y equals to, so I could rearrange this and write y equals to half of x minus 3 by 2, right? So positive slope and going with some, so I'll just sketch this line now. Let us say this is the line, which is, so they actually intersect at the center of the circle. So that is this line. Now y, x minus 2y equals to 3. So the line intersects the right bisector and you find the center, right? So that is how you're going to do it. So you get the point of intersection, and well, so that is how you get x value, then substitute x value to find the y value. That gives you the center, which in this case is 1 minus 1. You know the center, you need to find the radius, right? So you need to find the radius. To find the radius, connect the center with one of the endpoints. So in our case, endpoints are A and B given to us. So O to B will give us the radius. So calculate that radius. We took A, which was 0, 2 in our calculations. So that is the 0 value, and that is the 2. And then the center was 1 minus 1. We use the distance formula to find the distance as square root of 10. And then substitute in your equation of the line to get the equation of the circle. Is that clear?
Yeah.
So that is how you can actually solve this. It involves all these steps, and you should be doing all these steps in a sequence. Question number 3. Here is the solution. The line x plus y equals to 13 intersects the circle, which is given to us as this is the line x plus y equals 13 intersects this particular circle at the points A and B. So at 2 points, A and B. So as shown here, these are the 2 points A and B where the line intersects the circle, correct? So that is the diagram for you. Find the area of the triangle OAB where O is the center of the circle. Now, once the equation is given to us, we can easily find the center, right? So we know the center, so we know the point O from the equation itself. And now, to find the area, we have to find the altitude of the triangle. We know A and B also, right? So basically, we have to find A and B, right? First, we have to find A and B as a point of intersection, and then the height of the triangle. So, Amy, can you explain me this particular solution for question number 3?
Yeah. So when finding, so the first step is to find A and B. So those are the point of intersections. So since the line is given as x plus y equals 13, and the equation of the circle is given, we just need to sub in, so make x or y the subject, rearrange the formula. So in this case, we made x the subject, so it's 13 minus y. And we just sub that into the circle equation. So it would be 30 minus y minus 1 whole squared plus y minus 6 whole squared equals 20. That would simplify to 12 minus y whole squared plus y minus 6 whole squared equals 20. And then we can expand. So, yep. And then when you simplify and just take all the like terms, you get 2y squared minus 36y plus 160. Then divide everything by 2, and you get y squared minus 18y plus 80. And when you factor it out, you get y minus 8 and y minus 10. So that means y is 8 or y is 10.
Correct.
Yeah. So then
And then
we
you
just
find
sub
your
those
x
values.
and the point of intersection
Yeah.
is A and B. Good job. So once you
Right.
have point A and B, you know this is your equation of the circle. From here you can read the center point, which is 1 and 6. You have the chord A and B. Now you need to find the distance AB, that is the base of the triangle, right? Then you find the midpoint
Right.
and the distance from the center to get the altitude. So you have those two factors multiplied with half, give you the area of the triangle, right? So again, so many steps involved, you cannot avoid these steps, go through them. Perfect. Well, one you could do, but that is, you could use a distance formula also. So I'll just write here on the side, but not really required for this particular case, right? Not really required. You do have this particular line and you have the center. So you could use distance formula. What I'm trying to say here is this. So you have this particular distance formula. So you have the equation of the line, correct? And you need to find distance from the center. So you could use this and verify that the altitude is same as what you calculated.
Okay.
So,
Yeah.
so that is what I'm trying to say here. So you can distance formula to check. So it's a very fast check, no harm done, since there are too many calculations, right? So you may go wrong somewhere, but in examination, we can't afford to lose marks. So if you have time, you could always check at this stage. Okay, solution number 4. Amy, can you read this question?
Yes. The line y equals kx minus 2 intersects the circle x minus 7 whole squared plus y plus 1 whole squared equals 5 at 2 points. Find the range of k.
Correct. So this is the typical question. We want to find the range of k for different reasons, right? In this case, we want it for 2 points, correct? Sometimes 0 points, no points. So that is what it is. So the idea here is to find the value of k when it's tangential 0, right? But in my solution, what I did was I have taken this as an inequality, only because I want to teach you also how to work with inequalities. You must have done somewhere in some chapters, but it's a good idea to combine it right now. It's kind of a review on working on inequalities, especially when you have a quadratic equation, right? Linear inequalities are slightly simpler to work with. So let's see the solution, right? So that's the kind, so we are now not really solving your circle question. Apart from that, we are learning how to solve inequality in which quadratic equations involved. That is another GCSE question which you will come across, right? So we are doing 2 at the same time. That's the whole idea. So we know y equals to kx minus 2. We can isolate. We have already isolated. We'll substitute that for y here, expand and simplify this particular equation. Correct? This is one part. So one part of strategy is simplify the quadratic equation of in this particular form. So ultimately, we'll get an equation which is ax squared plus bx plus c equals to 0. After that, you remember the discriminant which we talked about right in the beginning. B squared minus 4ac, that is this coefficient of x is b, coefficient of x squared is a, and the c is a constant. If that is greater than 0, then we have 2 roots, correct? So in our equation, since we substituted k here, this equation will involve k, and therefore in our equation we'll have the value of k which can be found, and we have to equate b squared minus 4ac greater than 0 for 2 roots, right? Now greater than 0 means an inequality, correct? So we'll solve the inequality. That is what I was trying to say, okay? Now easy method definitely is only find these points of tangency. It's easy, just a calculation, correct? So you get quadratic equation 2 roots, you get these 2 values of k, and then you know in between is what you're looking for as an answer. Is that clear?
Right.
So in the examination, you can go with that strategy, save your time. However, we are also learning how to solve inequalities in this case. Okay. So I substituted this kx, simplified the terms, expanded, brought all the terms together, right, and came to an equation, which is of the form of this particular, let me just highlight this particular equation, which is in this form. Do you see that part?
Oh, yeah.
Now, clearly from here, what do you notice? What you notice is that the term A, can you tell me this is your term A, right? This is the term B, and this is your term C. Is that clear to you?
Yeah.
Now what I did was, I did this B square minus 4AC greater than 0.
Wait. So
B is 2k plus 14 whole square minus 4 times A, which is 1 plus k whole square times C, which is 45, and that should be greater than 0. You get this idea. That is a key step in solving this particular question. It is one of the most interesting questions in the series, okay? Got it?
yeah, I was wondering why, you know where it says minus 2kx minus 14x?
Yeah.
I was wondering why you didn't take 2x out, but then that wouldn't get it into the same form that you needed.
That is,
so I realized.
true. Yeah, you could have factored, but again, unnecessarily do not overdo things. Do you understand? This is the point. Then you'll have to again multiply, distribute. Don't do that. So wise enough to, every step counts in examination. Every step counts. The papers, especially the GCSE level A papers, are so well balanced over the years that you can't afford to lose a minute. And that is where the difference in the marks come, 90, 92, 95, 97, and 100 is all about this. Whether you were putting 2 and then again expanding, you lost a minute. Do you see that? You have lost that niche.
That's so true.
You lost the niche. You are at 99 now. So with every simple additional step, start deducting your marks when you're preparing, okay? So 0.51. It is going to affect solution of the other questions. You may do this excellent, but you can't get more than 5 if it is a 5-mark question. You get my idea?
Yeah.
Right. So we'll again now solve a quadratic equation, b square minus 4ac, right, greater than 0. Now see carefully, you have to reorganize your terms. If you get negative, look here, we got negative as a coefficient of k square. Leading coefficient should always be positive. Make a note. I've seen many times in calculations, if you keep leading coefficient as negative, you tend to make a mistake somewhere down the line, okay? So I added one more step. This I don't mind, but I want to keep leading coefficient positive. And when I multiply, do you notice the sign of inequality?
Switched.
Another mistake which students could make. So
they
when
keep
you
the same sign.
Yes, when you multiply with the negative sign, the sign changes. And this is what I call solving inequality. So what are we doing now? We are doing circle, of course, but we are also learning how to solve inequality.
Wait, so if you divide also by a negative inequality number, you flip the sign as well, right?
Yes.
Oh, okay.
Simple as that. 7 is greater than 5. How about minus 7? When you multiply by minus, both become negative, and now you know that minus 5 is actually greater than minus 7. Since minus 5 is on the right side of minus 7, it has to be greater. You see how the signs flip?
I didn't know why. I just thought that was a rule. Oh, see, now I understand it.
Simple as that. Do you understand? The right side is greater. That is how I try to explain my students. They don't get it because they keep on making this mistake. They never get it. I mean, very difficult. It's a very.
Oh my God.
Yeah. So that is.
You've blown my mind. Because at school from year 7, I've just been taught like you just got to do it, like you just got to know it. They didn't explain why.
Yes.
Now it makes sense. Oh,
Got it?
thank you.
Second,
Yeah.
in the beginning, I told you that you have to find the points of tangency, and the value of k is everything in between, right? I told you that.
Mhm.
Very simple. But that could be wrong also many times. I told you based on this, I made this positive. I made this positive. My leading coefficient is positive. That means what? That really means that my parabola is going to open upwards. Is that clear to you? So my parabola
Oh,
opens upwards, and when that happens, the point of intersections will be right there, and the portion in between, do you see, is negative? Zero.
oh, oh,
Zero.
yeah.
Does it make
So
sense?
you know that it's right. Yeah,
Does it everything?
yeah.
See that?
That's so clear. Oh my
In
God.
examination, if you are like slightly confused, these pictures should help you recall the concept and get the right answer. Do you get the idea? That is
Yeah.
how it is connected. So solving inequalities, think like this. Well, you could make a table of interval. I'm not saying that you can't do that. You can make a table of interval, test points, and do everything. That takes another
Too
2.
long.
Yes, that takes another.
Yeah.
So we have to save our time. That's the key. And that is how we
Efficiency.
should prepare and save our time right now. Okay. So this is what we,
Right.
and so of course, later half is not so critical. We can always factor all this. You're good at it, right? So just factor all this. You know your roots, correct? Now, these are my two,
Hmm.
which are half and minus 2 over 11. And so we want interval where the k is such that you get 2 points of intersection. So we are looking for the value of k, which is in between these 2 points. Does it make sense to you?
Oh, yeah. Wow. Okay. Yeah.
So that is how we are going to answer this particular question. Perfect.
Mm. Yeah.
This helps you to understand any question related with k, range, when it is tangential, not intersecting, intersecting, or whatever. Okay?
Does it have like all the elements to it then?
It has all the elements. Yeah, I could have changed
Oh.
the question, changing this to something else. You know the value of k now, right? So you can say,
Yeah.
well, it's not in between, but it is outside. That means it is outside means you could say like this. It is outside. It could be like this or that. That means it is not intersecting at all. You get the idea.
Right. Okay. Yeah.
So
And just to clarify,
yeah,
oh, sorry.
yes,
Yeah, just to clarify, if it said, let's say at one point, so that means b squared minus 4ac
equals to 0.
equals to 0.
Perfect.
Okay.
And those 2 points.
Okay.
A has to be either, let me highlight that in a different color, either minus 2 over 11 or half. These are the 2 values for
Oh, okay.
okay. So tangential, then those 2 values. Is that clear to you?
Yes.
Not touching at all, that means outside of these 2 values. Not within, outside these 2 values. Perfect. That is how
Right.
we
Yeah.
answer this question. So let's move on to the last question, right? Which is, I think, one of the most difficult questions in this particular series. So can you please read question number 5 for us?
Yes. Area of a quadrilateral with 2 circles. So 2 circles, P and Q, intersect at the points A and B. Find the area of the quadrilateral PAQB if the equation of the circle P is x squared plus y squared plus 10x plus 6y plus 14 equals to 0, and that of circle Q is q squared plus y squared plus 20x plus 16y plus 154 equals to 0.
Correct. Now, The point P, you can see from this equation, can you find the center of P? Can you please find, what is the center of circle P? Tell me, Amy.
-5 -3. So you do the inverse and half of the x and y, and then for circle Q it's -10 and -4.
Correct.
No,
So
-8.
8.
-8, sorry.
Minus means more negative, it goes to the other side. Earlier on, I wrote P this side and Q the other side, right? So let's be very clear about it.
Oh, okay.
When you see the equation of the circle, yeah, I realized my mistake, and so I want to highlight that this is the correct answer. So from the circle equation, do negative half of the x coefficient and negative half of the y coefficient to get the center point. Since both are negative values, right? We are in quadrant 3, right? So we are in quadrant 3 working here, and P comes first and then the point Q as shown here, right? So anyway, those are the kind of diagrams which we land up with. And now, since we find the point of intersection, you have to just equate the two. Perfect. And then solve for it, right? So when you equate, fortunately, x square, y square terms cancel out. You're not left with a very complicated equation, but you're left with a linear equation, which is y equals to -x minus 14. Now we need to find these 2 points, or when we land up with an equation which involves both x and y, what are we going to do next? How are we going to further solve it? Tell me.
Can we sub? Oh no. Wait. So solving. Oh no. Can we sub that equation into one of the circle equations?
Perfect. So at this time also students get confused. They've already used both the equations of the circles and they come up with a line. Okay.
Yeah. I just needed the time to think because I was like, oh, what do we do now?
What do we do now, right? So clearly we have one relation, which is y. We can isolate one of the, we can make one x subject, or we can take y as a subject,
right?
And then use any one of the given equations. Simpler is the better one to use. So we used one of those equations. So in this case, I substitute the value of y, right? So I substitute the value of y here. And then we have an equation only in x. Then you find x. You get the idea, right? So again, you're working, again, you're working with another quadratic equation. It's a long solution. And once you find the value of x, so you find the value, you get 2 values of x as expected. We want, the question also specifies. Well, if you're talking about 2 circles, again, they could be tangential also and give you just 1 point of intersection. That is also possible.
Right.
We not intersect at all. That could also be a case. But in this case, we are very clear that they actually intersect at 2 points. So we know we got 2 points. Very good. Find the y values and define your points. Now, we understand this structure, the quadrilateral, which we are looking into, is a kite. And therefore, we need to find the diagonals. So find both the diagonals, since you know A and B, the points of intersection of the circles, and the centers P and Q. So with that, find the diagonals, apply the formula. Area of this triangle is half of product of the diagonals. Is that clear to you? And then we get unit square as the answer for this particular question. Is that clear?
Yes. That wasn't as bad as I thought it would be. So yeah.
Yes.
I think the previous question was worse. I found it harder.
This one?
Yeah.
Yes, it is. It is indeed, especially because we have involved this inequality. But remember, you have actually solved 2 questions from GCSE level A. There will be a question on inequalities involving quadratic functions, right? And this will be another question kind of in your paper. So I hope that really helps you to understand the whole concept, right? So,
yeah, definitely.
Yeah. So, Amy, I would like you to provide me with your suggestions. We started with this unit on circles. We took actually 2 lectures to explain you everything. And the third one was to give you leverage so that you could easily attempt some very difficult questions, which could there be in GCSE level A. So with these 3, how comfortable do you feel with our lessons?
I definitely feel like so comfortable, and very confident in now attempting the questions from my book. It was quite impressive how in 2 lessons we've like done a whole topic. I didn't realize it would be done like this quickly. And yeah, I think what you did, like when we started this topic, you did like I thought we had to just go straight into it and start, but then I remember you doing like this overview lesson where we have to learn the basics first, and everyone always pushes the basics to the side, but like that's like obviously the base for a reason, so you can like build on that. So that was very helpful to do. And then learning all the formulas and everything, just knowing that they're there, and like when reassuring me, like when I find an answer and then you use that to check other answers, because the equations you've provided only take like a couple of seconds, and because these steps are like very complicated, it's easy to go wrong. So knowing you have these formulas just to check your answers is very like helpful. So yeah, yeah, so it's really good.
That's very good. So I'm happy that you have learned the way I wanted to teach you. And I've also seen applying, when I was a student like you, I felt there was a gap always, right? So even after
Yes.
speaking a paper successfully, I was never sure coming out of examination hall, like how well did I do until you get the marks,
Yeah.
which will reflect what you did, right? So, but with these kind of small things in the examination hall itself, you feel good about it. And you know you have nailed it.
Yeah.
so,
True.
so that is what I was
That's a
trying.
good feeling.
That's a good feeling, right? So you're really encouraged about all this. So that's what we want. So I mean, that was great teaching you this particular lesson. Also, we've done many more, and we'll continue in this particular process. And I hope you keep learning the way it is going on. So thanks
I
for
will do. Thank you so much, sir. I really appreciate it. Thank you.
and all the best.
Thanks.